Welcome to our probability unit in 7th grade. You are being given a packet today, and remember that as with your problem of the month packets, when you receive a packet, you're to put your name on the top and take very good care of it. If you lose the packet, you will have to pay for an additional packet, and that will cost you $1. So take good care of your packet. We're going to be working on it over the next week or so. Okay? Today we're beginning with listing outcomes 3.1, and we are beginning with this idea of theoretical probability. So theoretical probability, a theory is a best reasoning as to what one believes might happen in a situation, right? And we know that theories, scientists set out to prove them, right? Using experiments. So we're talking about theoretical probability today. And so probability is, when we look at the outcomes, this is a dice here. This is a die, right? A singular for dice, right? If I spin it, look what happens. Woohoo! One. You even have a talking die, right? So I can spin this die and we could get the number 1. We could also get 4, right? So how many possible outcomes are there on a normal die, on a 6-sided die? And hopefully you understand that a die has 6 faces, just like a cube, right? It is a cube. So probability, as you already know, is the number of favorable outcomes over the number of total possible, right? So if I ask the question, what is the probability of rolling any particular number? Let's choose the number 1 or 6. Actually, let's back up and just choose one number. Pick a number. How about the number 6? So what would the probability of me rolling just the number 6 be for a single die? Well, how many faces have a 6? Good. There is one face with a 6. Out of how many possible outcomes are there on a die? And I hear you saying 6, right? So we have one favorable out of 6 possible. So that is the probability of the event. Now, because that's a fraction, we could change it to a decimal. We could also change it to a percent, right? So probability may be represented as a fraction, a decimal, or a percent. So here's the second question. What is the probability of rolling a 1 or 6 on a standard die? Now see what you can do. Pause the video, see what you can do. Okay, if you're back, how many outcomes favor rolling a 1 or 6? And I'm sure you're saying there are 2 possible favorable outcomes out of the total possible outcomes of 6. Now, when we have a fraction, 2 over 6, what can we do? That's right, we can reduce it to 1 over 3, right? 1 over 3, and again, we could write that as a decimal. We could also write it as a percent. You know what 1/3 is as a decimal? Good, and so as a percent, we have 33%. So, one more question. How about this? What is the probability of rolling a 1 and a 6 on a single die? So, is it possible to roll a die and end up with a 1 and 6? No, it's not. So we would say that there's 0 out of 6 possible outcomes. 0 of them are a 1 and 6. So there is a 0% chance of rolling a 1 and 6 on a single die.
1.
Ooh, perfect timing. Now an outcome. An outcome is simply the possible result from an event. So if I flip a coin, possible outcomes are head or tails. Tails. Perfect timing again. Okay. It lands on one side or the other, doesn't it? Does it ever land in the middle? Like if you did it in the sand, if you flipped the coin and it landed in sand and landed right in the middle, like slicing into the sand. I could imagine you're thinking that, right? But let's just say that there's only 2 possible outcomes for a coin flip. So it's a possible result. That's what an outcome is. For a standard die, we know there are 6 possible outcomes, right? So 2 outcomes or 2 results to a coin toss, 6 outcomes for a standard roll of a die. Compound event. Well, a compound sentence, think about what that means. You can usually take a compound sentence and create two simple sentences, two or more, right? So a compound event is an event that is made up of two or more events. So an example would be rolling 2 dice. Another example would be, how about flipping a coin and rolling a die?
5.
With a tail. Look at that, we got tail with 5. What's the chance of that, right? Rolling a die and flipping a coin. So we're now going to look at how we can arrange the possible outcomes in a compound event. We can arrange the possible outcomes in a compound event in what is called a tree diagram. Okay? So it's used to show different outcomes of a compound event. Let's use flipping a coin and rolling a 6-sided die. So, what are the possible outcomes? We start with one or the other event to make this tree diagram. Okay, let's start with flipping a coin because there are just 2 outcomes, right? What are the outcomes, possible outcomes? And I hear you saying heads or tails, right? Let me see if I can get it to land on tails. Ooh, perfect. Let's see if I can get it to land on heads. Ooh, lucky day. That was not planned. I mean, that was hoped for, but not planned. So we have 2 possible outcomes, heads or tails. So they are at the top of our tree diagram, all right? Now, when we roll this die, we don't just have 2 possible outcomes, we now have what? 6 possible outcomes, right?
4.
So I could flip a coin, get heads, and roll the die and get one of 6 outcomes. I could get a 1, a 2, 3, 4, 5, or I could get 6, right? And the same is true if I was to flip and get a tail. I could get a tail with a roll of the dice at 1, a tail with 2, 3, 4, 5, or 6. Okay? So we could write these compound events as, I could get a heads with a 1, a heads with a 2, a heads with a 3. Right? And I could get a tails with a 1, a tails with a 2, and so on. All the way to tails with a 6. So when we look at this bottom list of outcomes, how many possible outcomes are there for this compound event? We see 6 and 6, or 12. We have 12 different outcomes possible when we flip a coin and roll a die.
4.
There we go. We ended up with tails and 4. This event here. That's 1 out of 12, isn't it? Let's try it one more time just for fun. Roll and, or flip and.
1.
Ooh, 1 tail. We've done tails twice. So there is our tree diagram. Okay, you do not need to write this, but let's think about this compound event. What if I rolled a die and spun a spinner? How many possible outcomes would there be in this compound event? Spinning the spinner gives us how many possible outcomes? And let's not count liners, okay? So we would say in this spinner there are 4, right? We could end up with blue, red, what looks like orange to me, and green, right? We've got those 4. And then once again, we have this 6-sided die.
2.
So each of these colors could be landed upon in combination with any one of the sides of the die, right? 2, 3, 4, 5, 6. And again, 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Okay, so, how many possible outcomes are there in this compound event? 6 plus 6 plus 6 plus 6. It looks like 24 different outcome possibilities, doesn't it? Very fun. And imagine if we added another die, I should say, right? We're moving from theoretical probability to experimental probability. So what's the difference? I mean, experiment, I see this little word experiment in experimental. So this kind of probability is the actual results of an experiment. What you get when you actually go and perform the event again and again, right? What happens when we do that? Theoretical probability is looking at, all the possible outcomes, but not necessarily experimenting. And in experimental probability, we actually create an experiment, we perform it, we get results. Okay, so some of you will do this with your science fair next year, and you probably have done it before. I'm using data from last year because I'm not with you in the class for this lesson today. So last year we had 7 Roberts and 7 Castaldi, so that's what you're seeing here. So what is the probability of girls existing in 7 Roberts class, or girls in 7 Castaldi? So the probability would be walking into the classroom where 7 Roberts class was and counting the number of girls there, right? Out of the entire possible number of students. So in 7 Roberts, there were 14 girls in class the day we counted, and out of 26 total students at class that day. In 7C, there were 14 girls in a class that had 22 students. So it was the girls out of the entire class, right? The girls out of the entire class. Now both of these are fractions that can be simplified, right? We could take 14 over 26 and call it, divide top and bottom by the GCF and call it 7 over 13, right? And in the case of 14 over 22, we could call it 7 over 11. So actually, this is a greater probability. 7/11 is greater than 7/13. 7/13 is getting close to being a half of the class, right? 7/11 is greater. If we change that to a decimal, we would find that. All right? So that's experimental probability, performing an experiment and getting results, okay, which we love to do. Now, how is probability different than odds? I'm sure some of you already know the answer. Odds are the number of events in favor of the outcome over not in favor of the outcome, okay? So what are the odds of rolling a 6 on a die? Well, we know that a die has how many 6s on it? It has 1 6 out of how, and then how many faces of the die do not have a 6? Very good, 5. So the odds of rolling a 6 is 1 to 5. When you add the favorable plus the unfavorable outcomes, you get the total number of outcomes. Okay, so in this case, if I add 1, which is one side of the die is a 6, to 5 sides that are not, I get the total number of outcomes on a die, which is 6 on a standard 6-sided cube, right? Very good. Okay, so on your packet, you can see that the front cover has a lot of terms and their definitions for your review as we go through this unit. And then you're going to begin looking at pages 72 through 75. And 72 is just more information for you to review to understand probability, okay? 73, you have 8 questions regarding probability in the tree diagrams I just talked about. And then 74 and 75 are about experimental probability. Answer all of the questions on 75, 1 through 12, and you will be done for today. I will see you next week.